Hello everyone, I'm Lachlan from Keen for Mathematics, and today I'm going to be talking about an interesting question that I don't think I've heard anyone ask, and most people wouldn't ask, so I'm going to. So the question is, why isn't there a two-sided shape? There's a three-sided shape, a triangle, there's a four-sided shape like a square or a rectangle, but why isn't there a two-sided shape? Now, you might know the answer and you might think it's obvious, and that's fine. But I think there's something to be said about what the answer could be. Not what is the answer, but what could the answer be, and does that give us any insight as to why there isn't one, and maybe why triangles are the way they are? Maybe we can investigate and we can find more about basic shapes by looking at this question. So straight away, if we're looking at what could the answer be, we need to know exactly what a two-sided shape means. So obviously, if you're talking about a shape, you might think, well, it's got to be connected. It's got to be something like this. A triangle, it was a bit of a wonky triangle, but a triangle starts at a point, goes down across and finishes back where it started. And we call this closed. And the way I think of something that's closed is, if I have a little character here, let's call him Timmy. Now, Timmy is inside the triangle, and it doesn't matter where Timmy moves, he can't get out. So he's closed in. He can't get out of this triangle. So for a two-sided shape, we need this object to be closed. So with two lines, two sides, two straight lines, I need to trap Timmy. And that's my aim. So now that I've seen that, I know I need two lines. This figure over here will have two lines. I just don't want to give it away straight away. There's two cases. There's the case that one of the lines is on a certain angle. It's slanted a certain way. And the other line is slanted the exact same way. It might be longer, I don't know, it might be shorter. It might be exactly the same. I've made these lines pretty much the same length. But that part, as you'll see, doesn't matter. The main thing that we need to concentrate on is that they have the same slant. They're leaning the same way. They're leaning on the same wall or whatever. Alright? So, knowing that, what we want to do is we want to see what Timmy can do. Now, Timmy over here was blue, but I'm going to make him red over here. So, Timmy, what you doing there, Timmy? Alright, so Timmy has to be inside the shape to start with, right? Now, in this example, if Timmy started, I don't know where the inside is. Because the whole point of the inside is that you have boundaries. And in this one, we can see that there's no boundaries. But let's test it anyway. If this was the inside, Timmy can escape up the top or down the bottom. And if Timmy was not on this middle part, if he was either side or out here already, he's already escaped. He's not in the confines of these two lines. That was a bit of a coincidence that I rhymed. So, in case one, Timmy's free. Timmy wants to be free. We want to trap Timmy. Alright? So, in this second case, what we want to do is we want to figure out, well, if one of the cases is the lines have the same slant, and if you don't know the word for that, the same slant of line, the same angle that the lines are on, means that the lines are parallel. So that's what we call lines like that. Now you might say, well, why is it called parallel? Now, I'm not 100% sure. But all you need to know is that this is just a definition. Parallel means the lines have the same slant. If you can't remember it, then that's okay. You can look it up. Alright? A lot of people get a bit ticky-touchy and a bit precious about exactly what things mean, and this is what you need to say, and this is the words you need to use. But in maths, there's so many words that we use so that we can refer to lines in a certain way, or to refer to objects that we use in a certain way. And if you just knew all of them off by heart, you'd probably have to sit there for a while just memorizing them, and that's no fun. So we'll learn them as we go, but if you don't know what parallel means, you could look it up, you could re-watch this video. There's lots of things you can do, and that's okay. Alright? So, with this first case, the lines are parallel. With this next case, we're just going to make it so the lines aren't parallel. But what does that mean? If this line, even if it's only just off, if I continue this straight line for a while, then this line, because it's not parallel, it's actually going to collide. The lines are going to, and here's another word, intersect. So I'm going to draw the intersection point up here a bit higher, so they actually cross. The lines meet at this point here. The lines intersect. So this is the second case, and I'd like to see you convince yourself that these are the only two cases. If, and I've kind of already done it, if it's not parallel, then at some stage the lines are going to have to meet. And in this scenario, let's put Timmy, well, again, I don't know where the inside is, but let's put Timmy here. And let's convince ourselves that Timmy can escape. So straight away, you might be thinking, well, Timmy can just pop out here. If this line was longer, all Timmy would have to do was travel for a further amount of time. By definition, these lines, these sides, they have to finish at some point. They have to be finite. That's another definition term that we have. So, eventually Timmy can just pop out the corner. If Timmy was here, he's pretty much already out, isn't he? Because he's not really trapped by either of these two lines. He could just move out of the way to make it clear. Same up here and same out here. He can just pop out. So, Timmy isn't trapped. So this isn't a two-sided shape. And this one, Timmy wasn't trapped in the first case. So this isn't a two-sided shape. So overall, there can't be a two-sided shape. Now you might have predicted that, and it's not that difficult to realise that there can't be a two-sided shape. But I think this mathematics that we use with intersecting lines, parallel lines, and the fact that the lines have to be finite, they have to finish at some point, I think this mathematics gives you a bigger insight as to why we appreciate things like triangles and why that's the lowest amount of sides that you can use to make a closed shape. And something to think about is if there was a two-sided shape, you might call it a doubangle. A doubangle. Because if I've got a three-sided shape, I call it a triangle because there are three angles in the shape. So here, if I wanted my shape, it can't have this overlapping part. I'd have to get rid of that. So this would be my shape here. But how many angles can you actually see? You can actually only see this one angle. One angle. So it wouldn't actually be a double-angle. It would be a one angle. Or some other variation of that. But now you realise, okay, so I know I can't have a two-sided shape. I know if I did have a two-sided shape, I have one angle. As soon as I make it a shape by adding my third line, because I can't do it with two lines, I make sure that there are three angles. As soon as I cut that next line, the first line and the new one create an angle, and the second line and the new one create an angle, and you get a triangle. Just like with a four-sided shape, you'd also get not a four-angle, it's called a quadrangle, or a rectangle. Alright? So, in this experiment, we've learnt that triangles are the smallest amount of sides, which is 3, that you can make a shape with. And I hope that you had fun. I'll see you next time.